All right, well, welcome back. Just like yesterday, you're going to need a pencil and paper. Please, if you don't have one in front of you, hit pause and go get a piece of paper right now. Hit pause. Hey, you're back. All right, so done with that card. Today, we are going to be learning about uncertainty. This is a very easy concept. I'm sure you'll be fine. Um, Uncertainty basically tells us that probability is not a promise. All right, and we certainly did see that last week when we were playing with coins. Remember, whoops, look at that. It already got smudged that quickly. We talked about the probability, if we're flipping a coin, probability of getting heads is 1/2 or 0.5 or 50%. And, any one of those ways of writing the probability is great. And then we did an experiment, and you remember that experiment. And we flipped that coin, 10 times. And some people got 6 heads, some people got 5 heads, some people got 8 heads, some people got 10 heads. It was all over the place. About a fifth of us got 5 heads, but that means that 4/5 of us got something different than 5 heads. Somebody got 10 heads, or was it 10 tails? I can't remember which. But somebody got all 10 heads. So again, probability is not a promise. You should write this word down. And this is the word we use that basically tells us probability is not a promise. We did, in fact, combine all of our coin flips together, and we got closer to 50% when we took all of our data and we put it together. I want you to pretend that we flip a coin 10,000 times. Now, a little bit of error is still going to occur at 10,000 times, but we would expect our answer to be probably somewhere between 4,000 and 6,000, if not between 4,500 and 5,500. We would expect it to be much, 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 much closer to exactly half. Mind you, that 4,500 out of 10,000 would be 0.45, which is really close to 50%. 5,500 out of 10,000 would be 0.55. Again, pretty close to 10,000, pretty close to half, pretty close to 0.5. Now, there's a rule that says, hey, when you do things 10,000 times, your probability is going to be a better predictor. And that, boy, I wonder how long they came up with, they took to come up with this crazy name. That is called the law of large numbers. When we do something 10 times, yeah, our results are going to be all over the place. But if we do something 10,000 times, the actual number of heads is going to be pretty close to 1/2 of those 10,000. That's called the law of large numbers, which again works very nicely. You want to write that down as well. It works very nicely with uncertainty. Uncertainty says we'll have some variety. The law of large numbers says yes, but that variety is going to be a little more consistent with what we expect it to be if we're doing this 10,000 times. Now, wait, what's that all about? 3 purple, 2 green, 4 yellow. Well, I want to talk about one more thing here before we leave. I have here 3 purple erasers. That's 3 of them. 1, 2, 3. Here, I'll put them so you can see them. 2 green erasers. And 4 yellow. That's 3. Hang on. Here we go. Got it right there. 4 yellow erasers. And what I'm going to do, I'm going to take these, I'm going to put them in this bag here, and I'm going to try to keep this bag visible so that you know I'm not messing with you. And I'm going to shake this bag up. Shake, shake, shake. Shake, shake, shake. Shake that baggie. Shake that baggie. KC and the Sunshine Band would be so proud. All right, so I have distributed those chips in there. Now, if I reach in this little baggie and I pull out an eraser, what is the probability of getting purple? Well, I hope you've had enough time to think that over. And I hope the first thing you did was add up 3 plus 4 plus 2 and gets 9. The total of 9 erasers in here, 3 are purple. The probability of purple is 3/9, which simplifies to be 1/3, or about 33%. The probability of getting green is 2/9, which is about 22%. And the probability of getting yellow is 4/9, or about 44%. And if you're like one of those clever math people, you're going to go, hey, those don't add up to be 100, those add up to be 99. Very good. But the problem is this is actually 33.3, this is 22.2, and that's 44.4. And in all 3 cases, I rounded down, and rounding down, rounding down, and rounding down again makes my probability total there 99 instead of 100. Now, so I'm going to reach in. We're going to do a little experiment. I'm going to do this as quickly as I can. I'm reaching in and pulling out. Oh, a purple. All right, purple. Boom. Okay, shake them up, reach in the bag, shake them up, reach in the bag. Purple! No, you're supposed to make a mark there, pen. All right, very good. All right, and yellow! $19. And $20. All right, now I chose 20 because that would make the math really easy. This is 8/20, which is about 40%. This is 4/20, which is about 20%. And this is 8/20 as well, which again is about 40%. As you can see, we didn't do bad. We didn't do bad. Got a little more purple than we should have. Got a little less yellow than we should have. I don't think you can do much better than that. 5/20 would have been 25%. So, you know, that's about as close as we're going to get on the greens. So, yeah, again, now those were not nearly enough trials for us to talk about the law of large numbers. This actually should be, I am surprised that turned out as well as it did, because uncertainty should have given us a little more variety. First time I made this video, which, by the way, did not work out for some strange reason. Those numbers weren't nearly as good. But hey, I got a cute little worksheet for you. A whole, I think, 4 or 5 questions on it. I don't think it'll take you long to do. Please do that. Email it in to me. I am working on coming up with a better solution than email. Certainly that was not pretty. But do the video, do the homework, take a picture of it, and email in the picture of it, and I will give you credit for your homework. All right. We will talk to you tomorrow. Have a lovely day.